Wickerson Studios. My name is Michael Wickerson, and I have not been posting videos for nearly a week, which means I either took a vacation or I was up to something. I definitely was up to something. What I've been preparing is a master series of scripts in Grasshopper to prepare teaching online, internationally, and also teaching locally here in Kansas City, and also to compile some incredible scripts to wrap my head once again around parametric design and certainly computational design. I have put this folder, I'm going to move my face over here a little bit, into 3 versions, and we'll get into the details of this, but there are a total of about 30 scripts at this time, and there'll probably be about 60, more than 30 scripts, but 30 sections, and there'll probably be about 60 sections by the time I'm done. So the second section continues here, and you can see these sections of what's happening, and then it ends with this plugin series, which I've yet to make. My goal is to have this done by the 8th of August, and I believe and I'm confident that I could do that. So these are up on, if you just give me a moment, my GitHub, and what is there is basically a version tucked into a private repo for MGSM, Grasshopper private repo, where I will put my Patreons, my current students, and my online students available for all of those scripts. Now, because they're so big and cumbersome, I'm going to break them into their sections, and they'll be divided fairly nicely. Now, they sit in GH Python script files, and that's it. I don't need any 3DM files to run the program, so it's a strict introductory and then quickly into intermediate and advanced Grasshopper. I also will pair every video in a series on this introduction to Grasshopper to intermediate and then advanced on my YouTube site as well. And if you want to gain access to the files, you could build them with me as I build each one, but it's going to be a fairly extensive series, should go on for a few hours by the time I'm done. So let's just close that up and take a look at what's here. So how I've set it up is the master script here, which I normally would have it all on here, but this is enough information to bring in here. I will have everything deactivated to start with as you open a file. See how long it takes just to select everything. So disabling all that, you'll understand the color codes. Let's push this back up here, and I am concentrated on the vanilla ribbon tools all the way from params to displays. And what I've done is I've echoed what's happening here in the data with a lot of scribble tools. So even though this is the first series and we're going to be looking at params, and these are the nodes that I think everybody should be accustomed to fairly quickly, this section's fairly nice as well. An introduction with some highlights and websites to Grasshopper docs, which will show you every node available if it's up to date, and food for Rhino, where you can get all your plugins. There are several plugins required for these scripts to open, but you can still open them without them. They just won't come up. And anytime I request, you'll see it in a scribble tool and where to download that. This is the first version of this, should be fun. The ribbon vanilla Grasshopper tools are basically params, math, sets, vectors, curves, surfaces, intersections, and displays. And my teaching and my instruction is based on the fact that if you know the math, sets, and vectors, the rest falls into place. And with sets becomes a very interesting section on data trees, also understanding masks and understanding offsets. We'll get into that. So looking at it under the ribbon, you've got the file up here. What is in the file tab that's worth knowing about? And these are some of the topics I'll cover. What is in the edit section and worth knowing about? And here they are. The view, display, solution, and help. Don't confuse the display here, up here, with the actual ribbon node display, which is here. These are different things, but things are intertwined. I'll cover everything from widgets to how to bake, and then where to get tutorials online and find node references. So starting with it, the setup's fairly easy if you take a look at this, and we'll zoom out. Each one of these are the ribbon tools sections, and of course this is only the first 4, which will cover params, vectors. We'll cover params, maths, sets, and vectors. And that's what's highlighted here. So quickly, as you jump in here, and I didn't mean to grab something like that, but I did. So I'll just have to pop my point on just to erase it. You see how small these nodes pop out because it's quite a massive script. But let's get rid of that because I don't want it. And let's take a look at the first section. I am one not to draw things out of Rhino. So the first section on params, we'll talk about how to import points, vectors, curves, lines, surfaces, breps, meshes, and geometries and surfaces out of the Rhino window, but we won't be looking at it initially, and also how to gain access to the geometry pipeline in regards to those. But that will fly through fairly quickly, and that is the first of, say, the 30 we're looking at. Immediately we jump into param inputs and take a look at all the valuable resources that are within that, and you'll see the application of one of the scripts. So as you section off this area, actually it's probably best to go from here to here, so you're only selecting left to right. Let's enable that, and you'll see that basically I highlight. It takes a moment because I have some image captures on there, and I have some graph mapper that has to load up. But as you go in here, you'll see that it's basic Scribble tools outline and the application to get every node up and running. Pretty basic stuff to start, but what I try to do to make it interesting, and here's an example of producing a fairly interesting curve, not getting into the expression nodes of the math yet, but using some of the tools that are within the params and input section. And then I quickly go down and show a wonderful example and pull in one of the first plugins, I think, besides bifocal, which is used to having, is Mesh Edit plugin. And I use 3 examples of that to do 3 different things with it as we go. So not only am I generating for perforating and cutting out holes in, say, a sheet metal piece, there's different fabrication ideas with what could happen here. It's all based on this old portrait that Bernadette Hornbeck drew me on my land. So that's an example of one of the sections getting into the second one. I'm not going into details because this is what I'll break each video into. And I thank and I credit people who've helped me along the way with this. Daniel Christoph is one of them, and I'm happy to be collaborating with this time, not on this project, but hopefully inputting what we are collaborating in into this document. Immediately after that, with param utilities, I throw data trees at you because they're coming. And if you understand data trees in Grasshopper, which is basically an understanding of not just lists, but lists of lists of lists of lists of lists, and how to access items and elements within those lists, you're going to do very well. Whatever analogy you want, be it trees or shelves in the library, you're going to find I jump really hard into it off the bat and get you visualizing what's happening in tree data, what's happening on your tools, what's happening in your param viewer, and honestly building up geometries as they layer and become more and more informational as you go. And you can see here we're already chasing a path of 0, semicolon 0, semicolon 0, semicolon 0, semicolon 0, with a certain amount of items on the corner. Of course, we're dealing with pretty simple geometries. And then I give you a highlight of what are some of the nodes we're going to be looking at in data trees. We're not even there yet, but it's interesting to realize that your geometries, you must be looking at them, not only the geometry that's visually being put out to the Rhino or ghosted in the Rhino window, but you have to think about the math behind that. And I'm coming at this not just parametrically, but highly computationally into what you can do. If you've been used to driving things by solids and surfaces, you're going to realize you'll be doing that by data and numbers. And immediately I jump into something with Galapagos, one of the easiest, it comes with Grasshopper, that you can start to find numbers and you can start to optimize them. I love using gene pool, I love generating forums, and I love using the data recorder to provide lifts and data and store that away. Lots of notes on everything. Anytime you introduce something new, there'll be a little blurb of what that actually is about. So that's number 3. Now remember, there's 30 of them here, and I'm hardly going into details here, but for those that want to stay with me here, please just keep watching. We've gotten through that params tab, and we're actually on to the maths and exercises in the maths. And here are my favorite math nodes broken into domains, operators, polynomials, scripts, trig, and utilities. Now, I must admit, as we get down here to scripts and we start looking at GH Python and C# nodes and VB script, you're going to realize the goal of that is to end up working with how I'm partnering with a fellow on bringing in my own nodes. And I just haven't, and the icons haven't even been made for these scripts, but they're being optimized and they will come in as a plugin, hopefully, that can be jazzed up with this script. So Let's just go back to the maths and really power this. And honestly, I mean it when I say the maths, the sets, and the vectors, if you understand those fully, there's nothing you can't approach, from mesh to NURBS curves and understanding of that. So immediately we go into domains. And let me, sorry for scrolling in and out so much. Let me open up all the math things and see what happens and see if we crash out, which we didn't because math's wonderfully quick. But you can see domains are being looked at right off the bat and understanding what they are and what are the powerful tools with them. Get them up and running and understand how to pull one together and put one away. Remap Plus is a cluster that I've used, but there's no point using it when there is a remap. And you might want to break down between bounds and a distance how you actually remap data and put it exactly where you want it to go. I then do the basic surface manipulation that a lot of people use, which is the two nodes divide domain 2 and into isotrim. So you can actually get your UMV coordinates up and running and have some fun. And then I have a little sample here that I'll start using the multi-pipe, which came out in Rhino 7 for subdivisions, just to generate geometries. Once again, a Galapagos is thrown on there to optimize it. And you can start seeing all the iterations and choosing from it all happening without you having to slide a slider around. Operators are going to be fairly simple, but if you're not used to math, you're going to want to delve into them. And mass addition and mass multiplication are worth looking at. You see example here of how I use factorial keys to put into a data recorder to generate lists, just to end up having these mass multiplication and addition work. Not too much coding, because I think the coding when it comes to conditionals, operators, and things like that, I think you really should be doing in a Python node or C# node. But it's nice to play off of this and look at your Booleans and see how things make sense when you get into the XNORs and NORs and all these wonderful terms, NANs and XNORs. It gets a little lost, but it is interesting to have a look at and know that it's there in the Maths tab. When it comes to actually writing, using the maths and the trig values, using the expression and a node over top of the function node is something that I'll prefer, and you'll see how we generate some beautiful geometries with that, mostly based in curve to start, and then also looking at tangent lines coming off of these things as well. And you'll see a little farther on that I actually not only get into all these polynomials and all of the trig functions, but that's how I actually like to drive the geometries with the math. There's a little bit of average here. There's not too much with statistics and machine learning, but once again, shaping things and considering smoothing, shaping. There's a word. Consider shaping and smoothing data with the utility nodes. I think I'll leave that word up there because I like it and I think I invented it. When you get into the special plugin for GH-Python Remote, that's a tricky business, and I don't spend time in this. But if you are going to be using things like NumPy and machine learning algorithms and scikit-learn, you're going to want to basically get an understanding of GH-Python first. I have some examples of nodes that you can double-click on and see the inner workings of what's going on there. Highly complex if you haven't done it before, but it will lead into being able to script in C. Some of these are dead simple. Some of them are fairly complex algorithms. It all leads to you producing your own plugins, and there's the parabola and hyperbola plugins that I'm working on currently. Kind of exciting to look at. And that becomes a little more complex as stepping away from Grasshopper into Visual Studio and putting all of your script in there away from nodal scripting. But if you take an interest in node scripting and you start to understand the logic computationally, you'll probably move in that direction. Okay, already we're into the Sets tab, and you can see here that I have set lists, and I will just forsake, and I like to select left to right. For some reason with this big a script, it seems to select all, including the scribble nodes. There's a little bug there. If your scribble node gets too small, you don't actually select it, and there can be trouble with it. Not that I have to disable the scribble node. So here we go. We jump into sets, and you can see sets really blows up on me because with sets comes so much data that you can play with. So we're going to grab here, and I'm going to enable, and I just enabled an awful lot. It's got to take a minute to just say, okay, what did you just open up, Michael? So getting in here to exercise sets, I'm hoping I don't crash. I'm thinking I should save the video at 14 minutes. Immediately, we're going to go in, and I use the data recorder. You'll reset it. I'll give you step 1, 2, 3 to get to that variable pipe, how to use the slider, and see what geometry you're generating. And I'm immediately going into starting to sort lists because that's one of the main things that comes in very handy. Now, what's nice around all of these, getting through here and learning the tricky ones, is you're starting to apply things like populate 2D and making a center box and using list items and using a clean tree. So you're learning other things as you're learning this way, even though you're focused on a few nodes. I distinguish between pick and choose and weave when dealing with data. I actually go so far as distinguish between merge and entwine and what that means for the data tree structure. Cross-listing, longest and shortest list, is worth spending some time on. Whenever I can put in a gene pool to generate geometry, I do like the multi-pipe tool because I think it does compare to what I used to play with in pipe, and certainly in variable pipe and mesh pipe. I didn't even bring in variable pipe here. It gets fairly exciting, but honestly, subdivision pipe tool blows it out of the water, in my opinion, for a nice clean form. What did I grab after that? Is a few things are working here, replacing items, probably because I just have to put in the data. Well, there's no data that's in the recorder. And what's nice is this data recorder is empty. Here's a nice example of how to generate a list. And there you go. Slid around the slider, produce my values. All my scripts are working. And I can take a look at what shifting list means, splitting lists, sublists, and what that does to that list. But things get complicated very fast, and I go into the path mapper. And the path mapper is a tool, and I'm unifying what's happening in BIM Corner with Daniel Christev in generating trees, even though you can generate a tree off of a C script. I have a very interesting one to do that. But I want you to start visualizing what's happening through flattening, grafting. I haven't put in what's happening here yet, but when you click on here, you can see what's actually, you can play around with it. I actually went so far into reversing the indices as a bit interesting equation, and then wanted to find out how to do that with the paths at different stages. And I think I actually figured that out. So pretty interesting to be able to flip your paths. Now, if that's not making sense, you're driving your points by these attributes, getting in there, and you're manipulating geometries like a grid and learning what to loft, what to move, and having total control. Think of drawing on multiple lofted pieces of graph paper, but understanding every point that's within that graph and where that will end up going. The power of learning Path Mapper, and I use this analogy, is that you have an apple tree orchard. You want to move it. Now, outside of going and planting a single tree somewhere else, waiting till it grow, and then pruning all of these trees and getting a whole forest to grow, imagine if you could take one seed from one apple in one of these trees in one of these fields, and as long as you move that, the whole field follows you along. And that's the power of using it. So sets and sequence I jump into. I actually don't even use sequence. I think it's kind of fun, but within sequence, I really do highlight the series node and the range node, which I think are so wonderful. And of course, you're throwing in little things that pop up spontaneously there, like Fibonacci kind of swirly node application. Then I go back into the maths pretty hard, and I actually deal with annotation, and I do only one thing in the text section, which is so minimal in sets, and just this whole script just to show you how I utilize the concatenate. So you're building a graph, you're generating something that's all data-driven, but nice to be able to think of coding and programming within not just numbers and floats, but actually dealing with strings. So an interesting tool to get into the text. Then we deal with sets of tree, and things really slow down and go into total detail. And what I really want to stress is the path mapper is great for understanding all of your data. The next one I really want to focus on are the nodes that actually allow you to produce masks. And masks are a way of getting at data, writing within a panel node exactly what you want, not dissimilar to the offsets in relative items and relative item. So that's another section that I go into, and here's a little example of just playing off of entwining information and seeing what it does to drive the data. I do take a close look at certain things, and here's a subtlety between merge and entwine. You'll notice that it does exactly the same thing to the data, except it does hold, where merge flattens everything, well, kind of treats everything and doesn't separate its paths. You'll see it maintains its paths. And this was useful for a robotics workshop that I took in Cairo. And I realized entwine was used a lot more for taking commands for the robot than actually the merge tool. So a lot of this, when it's learned, can apply to an awful lot of different things. Continuing to go, these two, pruning tree and trim tree, I leave for you. Consider the function of those two nodes and what they do to a data tree. And then tree statistics, breaking that down and understanding, exploding what's going on and what you're doing with that is something that you'll want to get into and break down all of its parts. You'll see a lot more param viewers and a lot more panels in this section. But like I said, shifting paths is a beautiful one as well to start to understand how to move things around. Just understand that one node. I draw up a pretty simple example. Wonderful generation comes from Daniel Christev. Once again, generate a three-dimensional box of points, grid of points. Branches and indices can be looked at, and you'll see how you build and destroy those or deconstruct them. Stream filters and gates can be looked at, and you might have seen that before. And then the custom user object on the C, this is one that I've written or found online that generates a tree of numbers, but once again, I defaulted to using this because you don't have the plugin. And you'll see how I can generate these cones on these points, and simply by using certain things like the split tree and running in all of these different masks. I've only got the last one plugged in. I can really manipulate a certain part of those, null off the other ones, and see what I end up having. Two other nodes to explore would be path compare and replace paths because they rely on the same knowledge of masking. Maybe this one not so much, search and replace. I'll have to take a look at that. And then an amazing example is off of BIM Corner, where he simply lofts and changes data and then pulls it back together. Really a firm understanding of what masks mean, all of the shortcuts. And with that, I would say go to BIM Corner and get the downloaded cheat sheet on masks. Matching tree, note simplify while doing that. Matching tree was an interesting thing that you actually quite simply match one data tree to another, which is an interesting little thing. And I like the icon. It just makes me happy. I think of balloons. All right, so I'm deferring a little bit here. I'm not making too much sense. Relative items, once again, dealing with offsets, which may look a little bit familiar to the masks coming off of split trees, but that's another thing to get your head around, and it's definitely great for stepping through points to produce your own kind of grid work or canopy work, and that'll make sense as you go farther in. And if you're used to programming in Python editor within Rhino, you're probably going to be able to understand that. And then really slow down and spending some time on the path mapper. Even though I brought it out once before, I'm really going to spend some time in this lecture, which I think is number 12 on path mapper. So this is going on a little long, but I'm just giving an overview of what's happening. I'm doing it for my own sake to see that everything's here. This video is going to go on a little longer, so if you want to just take a break or fast forward. Nothing in detail, but pretty exciting. Jose Luis at Parametric Camp teaches incredible things, and what I'm going to do is just quickly grab all of these and hit. It just takes a second to disable them to keep my script so it doesn't crash out on me. I would hate for it. We're almost done this first section, and I'll end this video here. And then I'll do a short 20-minute video on Section 2 and Section 3 as I come to complete them. Still working on just the tail ends of Section 2. So now we jump into vectors and what's actually there. And what is in the vector tab that's worth in grid, plane, point, and vector? No point going in the curves, surfaces, and solids until you really understand points and planes. A point is simply an infinite collection of planes, origin at that point. And when you start to understand that and how that radiates out in an infinite directions, you really start to do some beautiful things with it. So let's just grab this tail end stuff on vector, and I'm going back to the identity of Dr. Vector himself, which is Jose Luis at Parametric Camp, which I think just has taught me so much online. Let's enable that, and it takes a second to load up. I've got a little Galapagos going down here. I can see by those red lines. You'll start to be able to read your scripts from a distance, and I hope I didn't crash it out. If not, I probably will hit pause. No, I didn't crash. It's still going. It's just taking a minute to load up. Let's just give it a minute and hope we don't fail terribly.